Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/Security Weekly for an unlimited data trial and gain uncompromising visibility today.
Welcome back, everyone, to Paul's Security Weekly. Ocean and the Pell Center are partnering together to present Cybersecurity Exchange Day on Wednesday, March 18th from 9 a.m. to 3 p.m. at Salve Regina University in beautiful Newport, Rhode Island. You can visit securityweekly.com/Ocean 2020. Register for free and come and join in the fun. You get to hang out with many of us here at Security Weekly for a day. So everyone should come because you come to Rhode Island, to Newport, which is beautiful. In the springtime, even, it's still beautiful. And hang out.
Salve's in a mansion.
There are mansions.
No, it's actually in a mansion.
The Pell Center is a mansion? No.
The Pell Center is attached to a mansion.
Attached to the mansion.
But Salve's in that mansion. So part of their university, I used to go to meetings there all the time. It's in like one of those like coal baron mansions on the waterfront.
We're going to be doing all kinds of stuff there. We're not exactly sure what. We're going to have some panel discussions.
I'm on a panel. Yeah,
everyone should come so we can hang out. I mean, come to Rhode Island so we can just hang out and nerd out for a day, basically, is my call to action. We've got some security news. A lot of my research lately has not been news because I've been on vacation, but I'm listening to a new book where wizards stay up late. It's about how ARPA, it starts with the formation of ARPA, which was then ARPA, not DARPA, right? And how they set out for the contract to basically build the first iteration of the internet and contracted that out to BBN, which I didn't realize how closely tied that was to Boston and MIT researchers and Lincoln Labs. And they were basically, in this part of the story, they're designing the hardware and software for the IMPs. And IMPs are the very first packet switching routers. It was the first packet switching network, as I understand it.
From MIT.
It was just absolutely fascinating. And it's interesting how they have very similar characteristics and traits of what we think of today as traditional hackers, right? They drank lots of Coke, they stayed up late, and they were just like nerds working on new shit, basically hacking their way to build the first incarnation of the. And I'm on the part now where they're like, well, so these hosts have to connect to the internet, and they're going to need like essentially drivers, and they're writing the first specification, and they chose the person I can't remember all the names, that was the best writer on the team to write the specification for people who would have to write the software to basically be the driver, because they were all different operating systems to connect to the first iteration of the internet. I think it's really fascinating.
Cool.
It's a great book so far.
Yeah, sounds cool. I haven't read that book.
Should. And I also realized that in Boston, one of my son's for his birthday said he wants to go to Boston. And so I found this website that was like 17 of the nerdiest places to visit in Boston. And there's like a monument to Alexander Graham Bell. There's MIT Lincoln Labs. There's the building where where basically is the building where they house some of the first computers, like the TX0, the TX1, and the early PDPs. That was the stage basically for the other book I read, Hackers, Heroes of the Computer Revolution. They were like the first hacker group within MIT. And I'm like, I really want to go to that. If anyone can hook me up, anyone gives me a tour in my family, a tour of that building, I would love to see where like basically some of the first
That would be cool.
technology folks that were deemed hackers like got their start. That would be really awesome.
Yeah, I can be Uncle Doug and go along.
Yes, you should.
Hello, kids.
It'd be awesome. Kids,
help Uncle Doug with his drinks here.
Kids need to be. I think kids today are largely spoiled when it comes to technology. Everyone's got a phone or a tablet. They said something like the early computers was like thousands. I don't know what the extrapolation was in terms of computing power. Compared to what we have today is like unreal.
Like those old analog computers with all the cables and all that stuff.
Yeah,
it's like we've got 64 bits and we know how to use them.
Right, exactly. And it was all assembly. Yeah, cool stuff. Mm-hmm. Let's see. Hackers were inside Citrix for 5 months, according to Krebs. Did you guys see this?
Yes.
They said some pretty non-specific things that I think it's kind of fun to speculate. Like they may have accessed and downloaded business documents.
Imagine that.
And they were. I
mean, what do you do when you're inside for 5 months?
Citrix breakouts, right? Like VMware, for the most part, has kind of went semi-unscathed as like from a platform or hypervisor standpoint. Citrix, on the other hand, like there's a new Citrix breakout or an ICA vulnerability or some means of which to bypass security on Citrix. And many of these aren't even released publicly, but there's a ton that are public. And so the fact that if they're using their own tech and or these people have been in there, like there's tons of ways to do this. So it doesn't surprise me, but it is also concerning that they themselves do not have the security mechanisms and controls under control with inside their own environment to secure and lock down the pieces that would be needed.
Especially in like the early 2000s when there was a lot of Microsoft Windows worms running around, I was like, a great solution to this would be to virtualize the desktop, take it out of the user's hands so we can basically snapshot it, make it available, put it on a server where we can secure it. But we've almost come full circle where Citrix technology to do this is now the catalyst for a lot of these breakout attacks, Tyler, that you're talking about, right? Is that the typical use case?
You're talking about Citrix server breakout. So when you say breakout, you're not necessarily meaning you have access to get out of the VM to the hypervisor bare metal, right? You're talking about being able to execute code on the base host machine where either the VDI is running or potentially the VDI is running, but to execute code in a privileged manner. From there, something like credentials, anybody that's logged into a session with inside of that machine, those credentials are then compromised. And when you're talking about a VDI environment, that may be admins doing their jobs, SQL administrators, DevOps, finance, HR. All these people are coming in under different context in order to do their job under a VDI that's specifically served to them with the application served. All of those creds are then compromised, as well as the network resources in which those VDIs are accessing them and capable of gaining, permissions with inside of AD. So you're talking about a very large scale and very vulnerable target if not secured properly. And we're seeing a bunch of these hosts that are not secured properly with, you're talking about having to secure Windows, and then you're also talking about having to secure things like maybe they're only serving a specific IE app to consultants or maybe affiliates. This IE app has to be locked down, as does the Windows environment, as does the GPO for that particular user environment. And so it's very, very layered and very difficult for them to contain this. So once breakout happens or privilege escalation happens on that host, all of those particular contexts are then compromised, and that becomes a very big deal because there's a lot of things running on these particular Citrix servers.
I mean, you're almost better off giving everyone their own desktop and just turning on the Windows firewall at that point, to be honest.
Yeah, and that's so VDI in and of itself, like when done right, if you're talking about something where the golden image is rolled back and all of the persistent data is deleted at midnight every night, and you're talking about a golden image that's truly golden with proper lockdown and proper app segmentation and network segmentation and security between the different VDIs, then you're talking about a really good solution. You're talking about a low endpoint cost and very low endpoint security you have to deal with as far as physical and or having to deal with the management of those particular pieces. But that takes a little bit of work, and a lot of these places just roll.
That's what they had in mind. That was the original intent of all this, was that it's a golden image,
right.
and
you can roll it. I mean, it's very similar to what we're talking about with containers, right? It's a similar kind of.
And it was a help desk thing where when somebody calls in and says, my system's doing something weird, they just go pink and they blow a new gold image out, and theoretically it's going to work. The problem was, over time, those things evolve. They get people, I've seen this, they get people that say, I need a persistent image,
right,
and on and on and on. And the next thing you know, somebody's got one, and then they give it to somebody else, and all of a sudden there's,
persistent storage, we touched on it with our interview with Ian, in that storage, and I could see the eye rolling, right? It's very difficult to achieve different types of storage, especially persistent storage in some environments. A lot of applications don't require it, right? But now, like you're saying, Doug, you get down to an application that does require it.
And
you start breaking security rules, and persistent storage gives an opportunity to attackers to be able to hide files, to be able to hide malware, or put things on there that will execute when the environment is in fact rebuilt. But there are just some...
You get users that want persistent services, and they want persistent this and persistent that, and all of a sudden you got...
I mean, for example...
to do work, right? You have to have the ability to save files with on the network. Right. You have to have that persistence in order to do work in general. So
that's why you're
running into things that are going to be cause of business.
You look at something like Fargate and other technologies that persistent storage is more difficult, right? You need more control over the application. When I was doing MediaWiki, I'm like, well, users have to upload images, and those have to be stored on a file system, because that's the way the application works. And then, like, when people visit the website, the web server has to be able to serve those images. So I need a persistent storage volume that's shared by multiple containers. And now, depending on your environment, that's going to look different in how you accomplish that.
And it just keeps getting worse.
You're adding another layer to that, too, because when you're talking about a Citrix server or a Citrix environment, you're not talking about a cloud environment at this point either. You're typically talking about something that's on-prem. So you're talking about something that has iSCSI or SAN storage. And therefore, you're introducing an entirely different layer of security vulnerabilities, and or if you're able to break out of that hypervisor and hit that like bare metal, from that point, you're able to hit the iSCSI layer or network layer, and now it's in a completely different, things are exposed, such as multiple servers across containers that may or may not be, should or should not be accessed from any context that user has. So it gets very, very complicated when you're trying to secure and build defense in depth for something like this.
Yeah, it's interesting. It's an interesting segue into the article I had that was titled 7 Ways to Improve the Security of Mobile Banking Apps. And, I'm sure in this article they're talking, of course, about multi-factor authentication and encryption and blah, blah, blah. I think that really the way to start thinking about this is basically my application has to be resilient enough to run in a hostile environment. Assume it's an unpatched Android device. Now you have to secure your application. I mean, if this is not, and I know it's a buzz term, but zero trust, right? This is the type of resiliency now you have to build inside of your application. If you're not using some type of either open source or commercial solution that's being embedded inside your application that's basically running to help maintain the integrity of your app, you're just going to, Tyler's shaking his head, right? You've probably done app testing where it's like, if it runs on Android, like you have to have a really solid plan and implementation of that plan to protect your app, correct?
This is the mindset that you really have to start pushing down to the DevOps teams and getting them to understand as they're developing these particular apps. Like, you cannot assume that this particular piece of code or this storage of this hard-coded key is going to be safe or protected. Assume that you're on a rooted Android device. That makes them switch their mindset and have to adopt and kind of overcome and get creative around how they're actually solving security problems and developing the app from the ground up. But if you're doing that on a currently developed app, that becomes you've got to start thinking a little bit more outside the box and change how you're developing.
Developers are still trapped in that mobile devices are inherently secure because nobody targets them model from I know it's stupid, but it's from 20 years ago. And when people went to developers and said, mobile devices aren't that really threatened, so they were like, yay, thank you. And then they developed all these insecure apps, and now it's all starting to come home to roost. People are targeting these things as everything moves into that platform, and they've still got the mindset of, we don't have to really worry about it. You hear that all the time about iPhones or whatever. People say, you got an Android, you're screwed, but iPhones are perfectly safe. Somebody told me that. No, I know. I don't agree with it, but I'm just saying that's where those attitudes come from, because developers just want to develop and they want to get their product to market. And, every trip you put in there or every block you put in front of them is something they have to step over. So when they say, I don't need to worry about that, then they're really ready to embrace that idea, and you end up with these horrible messes.
Is it the same thing in the cloud, Tyler? Because we're looking at Amplify from AWS. And so that will run React, and it'll run it as an application you access over the web, or you can package that same app. So one of the beauties of React is it could be a mobile app too. I didn't realize even that Amplify supported a web-based app. I thought it was really just for mobile, but it's not. You can deploy any React app to it. But it's the same thing. Do you trust when your app is running in Amplify, you shouldn't trust the cloud environment and you shouldn't trust the mobile environment either, right?
Yeah, to an extent, right? Like you kind of have to look at that from your threat model standpoint. From the cloud standpoint, we're taking a different stance in which we're looking at the bare metal and the hypervisor, and we have to take a certain level of trust. Yes, zero trust is still a thing, and based on your risk appetite and your business use case, that becomes something as a business you have to identify. But you have to take an inherent level of trust with AWS or Azure or whatever platform you're on, and understand that the bare metal or the hypervisor to an extent is going to be semi-secured if you do the proper things. Now, outside of that, with that app accesses, whether that's federated and coming back into your environment or your servers, or has access into databases that have sensitive information, or you're sharing maybe a shared cluster or a shared host of VPC with inside of AWS.
Now you have to trust your ops team.
Exactly. You have to trust the deployment of that.
Yeah.
So that's where you kind of have to evaluate your threat risk model, as well as what you're actually protecting against and what is deployed in those particular areas that are at risk for what you're deploying.
Then it gets more complicated as well. You've got a lot of smaller financial institutes trying to compete with the Chase and the Wells and the B of A, but they can't afford an expensive dev team or a big fraud unit, so they're working on the fly, implementing all the same features the big competitor app has. So you wind up with something that on the surface looks just like the other guys, but it doesn't have the supporting...
Has all the same features the other guys has,
but it doesn't have
all the same security controls.
Right.
Yes.
I mean, there's a company up in this area by the name of Clout with a K, and they're in the financial fraud detection business. Had a talk from them a few months ago. What they do is amazingly complicated and incredibly expensive. So you're talking about their customers are trillion-dollar financial institutions. Your local community bank or credit union is not going to be able to afford them. So their customers have a huge jump on the security of their app, even without these 7 features that have been identified. I mean, just underlying transaction fraud, protection, security really needs to be there.
I saw this other article about out-of-band management consoles being exposed. And I find it interesting that we talked about this, I think, last week too, where Docker registries were exposed. And there was a relatively small number of them, like 900. In this case, they said they found 50. I mean, are those numbers really... I got to imagine there's a lot more being exposed to the internet than just 50.
But you know where those 50 are sitting?
Yeah.
They're sitting in
ICS,
natural gas networks and nuclear plants and stuff like that, where they were originally saying this is completely secure, there's a fence and there's armed guards and all this other stuff. And now all of a sudden it's like, let's plug the internet in so the Coke machine will be able to, reorder when it runs out, and you suddenly got a problem.
Well, not
now, when they're talking about out of band for these, are they talking about like IPMI, where you're talking about managing the baseband of a motherboard or a server or some kind of a PLC, a distributed cluster? Like, what is the context of the out of band?
The ones I've seen that were called out of band were
UpLogix. Have you heard of UpLogix before? It says UpLogix 3200 devices. It has a CVE. The vulnerability is it protects passwords poorly. We can only imagine what that. And I don't know what it is about these kind of applications, right? There was ones we used to use to get into Solaris, like Sun Microsystems computers that didn't have a built-in out-of-band management. When we talk about IPMI, like Dell used to have DRAC and whatever it's called now. HP had IO, right? Silo, whatever it's called. They changed names for whatever reason over time. But all like the major server manufacturers, other than Sun Microsystems at the time, this was 20 years ago, Dell and HP have their out-of-band management built in. In other cases, you would have to go purchase it's basically an Ethernet to serial
controller, actually probably kind of similar to the ones they use in ICS devices, right?
With the modem,
exactly
right?
those.
Oftentimes a dial-in modem.
And sometimes
Yeah.
a dial-in modems, because if internet was down, you had to be able to get into them remotely, and it essentially allowed you to console into the system and get a terminal over the serial connection, over Ethernet.
That was an early example. This is the exact same problem where consoles had originally been designed to be managed locally. Somebody gets bought. Like I saw some of these, this was back in like 2004, they were buying these companies and they had these kind of things. They were originally managed by a terminal connected RS-232.
Yep.
Somebody bought the company and moved the management of that operation to another city. They put a dial-up modem on the front of it, plugged that into RS-232, and people were war dialing them because they didn't even have logins. It was just like if you connect the phone number, it's like war games. Boom, you're in. You know?
Or it was that, but see, the way I understood it was oftentimes that terminal session or VTY port it was static. It would stay open. So if I connected to it, and I go over Ethernet, I connect to that server over serial now, and I authenticate as root because I have to troubleshoot a problem, right? Or even if whatever, I'm at a root prompt through sudo or whatever. If I don't log out, whoever can connect to that is just staring at a root prompt. I've done this on Dell Drac before.
Or you just switch to that terminal.
You
could actually switch to the terminal.
You're sitting in a root prompt.
This is still a thing. Like, I'm not calling out the financial market by any means, but I am. Like, most of the core networking or core systems that a lot of the financial markets use at a bank, whether that's Scimitar or one of the others, a lot of these small or like small city or medium-sized banks leverage this very same technology. Either it's a dial-up modem that calls in and has a backup terminal, or you're talking about a VTY session across serial that once opened through Ethernet, that session is open, and that means the application that may have opened that as part of the application programming also means that it's open and you can access that through some rudimentary, like old school techniques.
Yeah, and maybe it's just configuration that would control the timeout, because I know on, for example, Cisco devices with
but then
iOS,
people would have to log back in.
Yes, then you have to log back in.
You have to set that on a Cisco device.
You have to set that on a Cisco device.
If you don't set it, it's just like connect and you're in.
Forever.
You own it.
Right.
Yeah, you're at root. I mean, there's no. I mean, that's the first thing they teach in Cisco classes.
Cisco had to deal with that though. Like as security, they had to advance and like learn their lessons from getting slapped on the wrist so many times. A lot of these financial organizations, or even like the very, very few core applications that run banking software across the United States for like Swift payments or any of the core applications, these people aren't getting the same kind of wrist slaps, so they don't have to adopt as quickly, and there's not a whole bunch of competition with inside the market. And so really users don't have a big choice, and so security is not a big concern as far as having to adopt that very quickly. Obviously, financial loss is a big deal, but I have not seen that be a motivating factor in most of the cases that I've dealt with.
It's like taking you right back to war games, right?
It is. It's
exactly that. I mean, it's in the book I'm reading is one of the reasons why they wanted to create what is now the internet, because researchers and folks working for the government and ARPA would literally have terminals. Those terminals over a modem, right, would be connected to the computer at the university across the country, and they had all these terminals set up everywhere. And they're like, well, wouldn't it be nice if we just have one terminal and connect to all of the other
attitude
systems?
Was nobody can figure this out. I got told by a military officer once. He was like, "Son, ain't nobody but you and Mr. Spock going to figure this out, so we're not worried about it." And
you sound like the guy from War Games.
Son, I'd piss on a spark plug if it'd do any good.
I would trust that overgrown pile of microchips as far as I can throw it. That's his line from War Games. And he says it in the exact same voice as every general. And he was the general in that movie, which is really funny.
Buck Turgidson. Sorry, that's the general
Buck.
from...
Of course it had to be a Buck.
Well, Buck Turgidson's the general from Dr. Strangelove, but...
Oh, that's hilarious.
Well, but back in the 70s, it was complicated, or in the early 80s, to figure out. You did have to be a rocket scientist to know how to reverse engineer it, but those days are so long past.
Well, that was the game back then, was getting the manuals.
Right.
Because there was no internet to get the manuals.
Or social engineering the engineers, which was really easy, because you call them up and they're like, well, somebody's interested in this? Sure, I'll tell you the whole thing.
Right.
Because I used to do that all the time.
Or they wouldn't tell you. A lot of times they wouldn't. Well, Atari was notorious for not telling anyone how their systems worked.
I would just we call these guys, and they were just they love to talk. Really, you're interested in that?
Persistence.
Yeah, I was really interested in that. Like, what's the terminal number? You know, and they're like, oh yeah, cool. Yeah,
It's awesome.
Oh, helpful.
poor guys.
Oh, so what is the? All right. So first we have to talk about the hack of the DNC and whether it was Russia or not. I tend to be of the belief that we have pretty significant evidence that it was Russia. I mean, we're all pretty smart people, smart people listening. We've read. I mean, there's the media and the exaggerations, right? But when you get right down to it, and you look at the malware, you look at even the motivations and intent. And I know attribution is hard, but this, I mean, to Lee's point, this isn't rocket science either. Like, there's a lot of things that just evidence that points back it was the GRU, right?
Son, them Ruskies done it.
Yeah. Well, there's that.
An interesting point around that, like something that you kind of have to wrap your mind around for a little bit, is the fact that people like the DNC or elected officials or particular like campaign groups, as they're operating independently, right? They're operating under their own budget. Typically, they're operating under their own infrastructure or, maybe even devices. It's not as though there's a corporation that says, hey, you're doing an election as part of the DNC, like now you're under the DNC, merge all your stuff. So the fact that they found an email server and the GRU leveraged that to allegedly do some things. So
these are soft targets.
It's not a big thing. Yeah, these are soft targets.
Right. Because of the nature of it, because they have to operate independently, right? Like
yes,
it kind of comes back
all
to
over the country.
Yeah, it kind of comes back to you should never create, design and implement your own encryption algorithm. But in this case, like you basically have to design and implement your own network,
and it's done quickly.
And it's done
because
quickly.
It's kind of like, okay,
right.
we're going to do this. We're going to have a campaign. Let's hire Lenny's cousin. He'll come in and set all our stuff up.
Yep.
And the next day they come in and they got a bunch of computers sitting around, and somebody bought a router down at some store, right. And they plugged it into the network, and they were like, "This is secure, right?" And this high school kid that is the guy's nephew is going, "Yes, sir, it's secure."
Yeah.
Well, I mean, on top of that, too, you're talking about campaigns that may or may not fail, right, based on whether they get elected. And so you're talking about entire infrastructure or offices that get spun up for a particular purpose. Maybe there are lines and routers dropped in with, drops that hook in with a VPN to the DNC headquarters or whatever, central location they're using to collaborate. These particular office locations are temporary. However, a lot of the connections and what's being used get left up well past when the lease is up and or people move out.
Interesting.
Bob may or may not have experience around finding those particular locations and open circuits that are still, tying back into particular networks. It's a whole network. It's a connection. So
right.
It's not surprising at all from that standpoint. And the fact that like a nation state or APT use this, I don't see that as a very big stretch. The evidence is very, very clear as far as maybe who they think used it, but the opportunity was there to use it and someone used it. So the point is really like, how do we get past this particular point in order to better disseminate information and not have this kind of way into whatever decisions people are making as far as the public goes. The public is going to be uninformed, and this particular piece should not affect one way or another based on whatever this is, right? I don't see that as a mitigating factor other than mass media propaganda.
Well, so now let's talk about some potential mass media propaganda. Apparently Trump offered a pardon to Assange. Now, Trump went on a pardoning rampage lately. And
Charles Manson, his pardon.
All presidents, right? All presidents do.
All presidents
do.
They have that power, and I would say, I don't know what the track record is, but I'm sure you could look up the data. Probably every president that has taken office in a certain time has probably pardoned someone at some point.
They tend to start pardoning people after the election if they think they're not going to be reelected.
Right.
And then if there's something heinous, but they also tend to pardon people who are big donors, who have a lot of lobbying power.
There's political motivation,
of course.
Yeah,
and they all do it. It's just Trump's people are not very good at hiding things.
Very true, because now he offered, allegedly offered pardon to Assange if provided Assange denied that Russia had anything to do with the DNC hack.
And I mean, they're just not good at covering this stuff. And I think
Now, go back to our first part. Apparently, he's asking Assange to lie.
And
can we just establish this?
I think they just don't care, because I think that his organization realizes that no matter what they say, he may jump on Twitter an hour later and say, "Yeah, I told him you can't handle the truth," because and then they all look like idiots. So they just basically leak everything, because what else can they do?
Yeah,
he's going to leak it if they don't. So they figure, why don't I just go ahead and leak it and let the story be out there, because it doesn't hurt us anyway. I mean,
so does that mean the most reliable source is actually from Trump himself?
Yeah, that's
maybe. I mean, read the tweets. But I think they just don't care, because the only thing that affects politicians are money and their numbers. And his numbers don't change no matter what he does. So he can go out there and eat a baby in the Rose Garden on camera, and his numbers will still be right where they are today. And so he says, I felt like eating a baby, I'm going to go out there and eat one. And his people all go, oh, that's a bad idea. You shouldn't eat babies. I mean, it's going to make you look bad if you eat a baby. Come on. And he says, nope, I'm eating a baby. Get me a baby. I'm going to eat it.
I mean, but it seems like there's some denial that this ever happened. That this pardon was...
Well, you got to deny it.
But you got deny.
But then watch, tomorrow he'll tweet, of course I did. Why wouldn't I?
Yeah.
And then they all look like putzes, because they denied it. And then he fires somebody who denied it. And it's just...
And the cycle continues.
Oh, yeah. It's got to be a fun place to work.
Attribution sucks, right? Like, attribution is hard to begin with.
Mm-hmm.
Yep.
Then you add in politics on top of that. And then you add in, like, disinformation and or, like, political / country APT style, like, disinformation.
Right.
Uh-huh.
So really,
information out there, like,
that.
well, how do you trust it? Like, because I read where, Putin never liked Hillary Clinton, and therefore that was some of the motivation behind it. I'm like, well, that's interesting. That never comes out in mainstream media, right? Because that didn't come from mainstream media. You'd never hear.
Nobody likes Hillary Clinton,
because that's not sensational enough for mainstream media.
They don't pick it up. It's on.
So, like, is that maybe
page 45?
Right, closer to fact. Who knows? Yeah, and what do you believe now when you read stories like this? You don't know what to believe anymore.
His people could be putting out both stories. They leak the story that he did a bad thing, and then they leak the story that he didn't do it, because both of them put the word Trump in the headline, and there's no bad headline. So
actually, if you look at, like, something that one of our Intel Ops ladies posted, Cindy Otis, she gets into some of the kind of advanced kind of semantics around disinformation campaigns and playing both sides of that. And there are several examples, not only like one from looking at some of the Macedonia stuff where there's some media campaigns where people are being hired from Macedonia to do particular, like, disinformation. But if you look at people playing both sides of the coin and you're looking at, like, what the information is coming out and the very complex nature of how these operations are handled, especially long-term by, say, APT groups. Look at China. China's in it for 100 years plus. As an American mindset, we have a really hard time grasping how to strategically look at a problem from 100 years and operate outside of a 4-year campaign, window. So looking at this from a high-level strategic APT group and multiple sources of disinformation and what that information is doing long-term, maybe causing reputation damage between both of the groups for a long-term strategy we don't even know, that's when you start to really get into the nuts and bolts of the strategic planning, understanding APT mindset, and understanding disinformation as a whole.
I'll tell you
what book gets into a lot of that.
What's easier to understand is my story number 9. U.S. and U.K. formally blame Russia for mass defacement of Georgian websites. I can tell you there's probably not too much, like, introspection we need here.
Yeah.
Like, yeah, probably Russia. Like, just saying, based on, I don't know, history and facts, probably Russia, right?
I'm pretty sure they admit it, like, openly.
I would think so. Yeah, it's a military. It's like, oh yeah, it's those Georgians. We got to fix them.
I think it's the agenda of Russia to, I think, want to, essentially rebuild the Soviet Union and take control over the other countries. It's no secret. If you look at the relationship between Russia and Ukraine and the relationship between Russia and Georgia. I mean, it's not good in any way, shape, form, or fashion. So when this stuff happens, I mean, there doesn't even have to be an investigation.
Well, it's an old tactic.
When you run it's
the destabilize,
yes.
Come in and be the savior. You know, so when things go to hell, then we step in and save the day.
I mean, they've been doing that for a couple of weeks, and then it runs out.
They've been doing that since the 50s. You know, it's like
from that standpoint, though, like as offensive security practitioners and as people that have to live in this country, right? Like,
if you're going to attack Georgia, you can always just blame Russia, and you can hack Georgia all day long.
There you go.
There you go.
well, so there's that. I mean, there's that.
There is now.
But
yeah, my command and control infrastructure
of, like,
now lives in Georgia.
How do we as a country, or how do we as the people electing officials that don't understand this kind of information, what kind of stance or information or education can we provide them to really add value into this whole situation, right? Like, Russia did something wrong. They're using cyber in a way that, we've said, hey, that's an act of war. If you did that to us, like, we would F you up. Like, don't do that.
Yeah, but we can do it to you. That's totally fine. We can do it to you.
Yeah.
Yeah.
Right. The U.S. can do it to other countries. Just don't do it to us.
We've been doing that we've been always doing that.
That's true. Even before the internet.
Or how do we, like, as a country, take a stance and provide education to those people that are making these decisions and have to, at the end of the day, provide guidance to their leadership as far as, like, hey, this happened. What do we do? And these people are like, I don't know, this is outside of, like, this is like SpaceX. This is outside of our AO. This isn't something we have to deal with. So how do we provide that value and understanding?
You'll see some more stuff like the Congressional Cyber Caucus and organizations like that, which got formed, were bipartisan. So there were literally people from both sides, even people that were really extreme on other issues, talking to each other and bringing people in to testify to those groups. And they were asking good questions like this. I think
that the knowledge is increasing, but I always think it's been kind of the not secret weapon, but a tactic used by various governments where they don't necessarily need to go get permission from anyone, that there can be, groups within the governments that are attacking other governments, and that kind of stuff happens. And when you get called out, a lot of times in history, the congressional hearings, people are confused. I do think, Doug, to your point, it is getting better. And I think over time, a lot of this stuff is not going to be misunderstood and just over people's heads.
There'll be new stuff to be misunderstood.
There'll be new stuff to be. Oh, that's a great point too. So
it's setting precedents, though, as well. Like, we really have to kind of understand what is the best course of action, looking at the whole strategic picture from an offensive standpoint and our long-term gain outside of the political ramifications of whatever we're doing. And then providing some guidance around the technical aspects that, we may or may not understand better than whoever we're advising.
Offer your services. Offer your services to your representatives. I mean, Jim Langevin is one of our representatives in Rhode Island, and he was one of the chairs of the Cyber Caucus. Their people would call and ask questions.
Yeah.
And if they know who to call, a lot of times they don't want to be stupid. They want to do what's right.
I mean, to Langevin's credit, him and his administration are very involved with cybersecurity,
and a lot
folks.
of other ones are too.
Yeah.
And other people would get involved because they have to go to these hearings and they would like to be better informed. So if you talk to their staff and talk to their staffers, tell them who you are, tell them what you do. And they may call on you and say, "Can you write a white paper for this? Because I've got to testify next week to the DoD, and they want to know about hacking back." And I mean, I wrote something about that once because they didn't really know what it meant, and I said, "Well, it's basically, let me explain."
Yeah.
And that helps them to go to those sessions where they're trying to decide what laws should be there. Because there was a couple of news articles this week, I didn't put them on there. The UK said they were going to start exposing and shaming other countries that were doing this stuff.
Yeah, but that's a slippery slope too.
It is.
I don't know if it was on. It might have been off. We were having this conversation about how, over time, nation states have learned how better to hide their activities, because now it's kind of out in the open that nation states are going to attack each other, right? Basically, they're using that to their advantage. Now you can blame whatever on
North
whoever,
Korea,
right? But now we know from malware and tool signature that belongs to North Korea. But now with the internet, we share information like that all the time. So if I'm Russia, maybe I go take some of that code. And this is, there's huge precedence that this has happened, right? I go borrow some of that code. And I go, well, shit, I don't want to look like a nation state. And then there's this other maybe U.S. group that's got this really like script kiddie stuff, and it works well enough, so I'll use that. And maybe someone will blame someone in the U.S., maybe someone will blame North Korea, but like everyone's going to be pointing fingers at each other. But really, it was, for example, Russia that was behind the whole thing.
It's the same.
I firmly believe that's happening.
It's the same thing with hacking back, and this is why so many people were opposed to this idea. Because what if you get set up? What if you say, well, we're going to hack back. I hired some hacking crew, and I think these guys in the Ukraine hit our website. We're taking them, because I was in an exercise where this corporate guy was just like, I'm going to hire all the hackers I can find, and we're going to take those guys down. And I was like, well, I would just disguise my stuff so it looked like somebody I didn't like, and you basically get smurfed. And he was like, what does smurfed mean? And I was like, it's when you go in this bus station.
It's really
that plays into the whole like disinformation and like long-term strategic game that people often aren't using that kind of mental muscle, right? You have to think long-term. Again, if we're thinking about China as an APT group and we're thinking about a 100-year campaign, in order to frame and set up the politics for, say, Iran and the nuclear program for the next 50 years, we really have to frame these people. And in order to do that, there's like X, Y, and Z smaller campaigns and X, Y, and Z smaller goals that have to be achieved and be put on other people in order to set this up. And often they don't know the outcome or how this is going to play out. So we really have to
what you're saying
is
those
mindset.
Those diplomatic relations that we had with China, I believe from the Obama administration, China just said, yeah, that's great. Now when we hack the U.S., we're just going to make it look like someone else to maintain those diplomatic relations. That actually makes perfect sense.
It does.
Definitely.
Very Chinese.
That's from a long-term strategy game. Like, they're not in it for the short term.
Right.
And as Western mindset and as Americans in particular, this is something that is very, very lacking across the board, even in security professionals, to look at the attacker mindset and look at the APT groups and realize our mindset and our focus is 5 to 10 years, maybe at max. Sometimes it's less than a year to 3 years as far as an organization's concerned. And so we really have to understand they're in this for the long game. What does that mean as far as how we're evaluating what we're looking at from IOCs, how we're looking at this from strategic standpoints, and how we're building our defense in depth and or offense in depth to collaborate and correlate and attack back at these particular targets. So there's a lot more to this than people realize as they're starting to adopt this understanding of what's going on in the world.
Now, speaking of targets, and I think some may have read this headline and thought it was FUD, right? But then you look at the firm that performed the research, and it's Dragos, so instant credibility. They analyzed 438 ICS vulnerabilities covered in 212 security advisories, including engineering workstations, HMIs, operator panels, and industrial network equipment and field devices, which paints the picture of a pretty wide attack surface. I don't think they said in the article like where most of this stuff is deployed. I'd imagine it's not just U.S., right? I'd imagine
it's all over the world because they all use the same stuff
or similar stuff.
Well, there's like about 7 basic things they use in these ICS systems, and they're controllers that are made by the same people, and it's just like Raspberry Pis. It's a Siemens 7 or something like that is one of them,
right?
And they use the same ones because it's just a Raspberry Pi. You can program it to do whatever you want, solder stuff onto it, build a control board. And now you got that thing running gas turbines and switches and whatever else.
I mean, there are only so many vendors, right, Tyler, that make this particular software and hardware specifically for industrial control systems.
Yeah, and this in particular is very interesting because, the visibility that Dragos is getting in like building this data from is more than likely from a lot of their customers and or the visibility that they're provided through their platform, right?
Right. Well, they've been Rob's been researching this stuff for a long time.
For a very long time, yes. So his looking at like math theory and how statistical analysis works and his ability to pull a particular subset of the group across a larger group, he's in the majority of the places that is going to have some visibility and understanding around these particular pieces. So these numbers are probably very accurate. If their math and statistical analysis is correct around like the polling, then yeah, he's probably pulling a pretty good amount of data from each individual place that he has visibility in, which that subset is probably a good indicator of what the entire picture looks like. Now, he's not getting visibility into a lot of places, and there's a lot of things that he may or may not see, but based on what they're putting out from the visibility they have, I think this paints a very good picture of the kind of attack surface that, from an APT standpoint, you have to have that kinetic advantage. You have to have that ability to cause either monetary control and or issues with inside of an organization or a country, or you have to have kinetic or direct control of things that cause, panic, chaos, and harm, right? And that's ICS or the financial market. And so his visibility into the ICS side of this provides a very big picture of, this is a pretty big attack surface, and we do have a lot to kind of think about and worry about, and here's what you can do to prevent these particular attacks at this attack surface. I think it's a great resource that a lot of places should start looking at.
And my fear is that there is still a big attack surface, that remediating these vulnerabilities is still extremely difficult for these organizations because of the environments that they're in. I mean, this is something we said from day one, and especially when the Aurora project brought a lot of this research into more of a spotlight, right? Is that we're still in this place where...
But people are starting to look at it. I mean, NIST released a report on ICS. MITRE just released a TAC for ICS. So you're starting to see more focus on these issues and on these resources because they are out there. They are massive. They're very old sometimes. They were designed for massive longevity. I think they said the average design spec was like 25 years on ICS, that it was supposed to be running for that long. So it's out there, and it is a huge attack surface. But I think people are starting to go, uh-oh, this could be the next great problem.
Yeah. It's very, very typical for us to see like most of these systems and designs to be end of life or leverage for up to 20 years.
Yeah.
This is one of the common things that we teach in the assessing and exploiting ICS class is you have to understand that this is not your typical IT environment. Well, whatever you know in IT can correlate and provide value into the OT environment. And you need to bring those because that's what's missing over here is a lot of the kind of out-of-the-box thinking, a lot of the lessons learned over the last 20 years from IT. That needs to be applied in OT, but with the understanding of how to do that properly in an environment that has loss of life, that has the capability to cause problems, that has problems that you not necessarily can identify or answer or mitigate with the common mitigation, such as patching or updating a system. You can't always do that with an ICS environment. So you have to kind of think outside the box, bring your knowledge from IT into OT, and be able to identify those and then creatively think and build a solution for many of these organizations in order to provide value to them. And that younger generation that's coming up, many of these OT people are hitting their retirement peak. They're hitting their end of life. And there's not a whole lot of IT people jumping over to OT unless you're seeing the value of that. So if you're interested in anything OT or ICS, it's a big deal.
I think it's interesting that in IT we can lose control of our systems for a certain period of time and still recover from that. And the impact might be some downtime. And we've all worked in IT as administrators, and the mail server goes down, it's an event, it happens, and we recover from it. When you can't translate that to OT. There is no losing control of your systems is like the worst possible. It is
not
just,
a
it can't exist.
Generating event.
Right.
It's a
not
loss of life event.
Exactly.
When the sawmill goes haywire, it gets ugly fast. Yeah.
Not a thing. Loss of control of your systems. Again, I think Tyler sums it up nicely, right? It can lead to loss of life very quickly.
It's the same cycle we saw in IT, though. It's the sort of now we're trying to educate. So you're getting asked the questions. People are going, could this happen to us? and you have to go through the whole gyration of, yeah, but come on, we're not at, who's going to target us? We're a sawmill, And,
but my fear is the way that I think we're dealing with that well in IT goes back to our interview with Ian. It goes to when we use the DevOps, but I thought what we did great in that interview was identify all those different components of your orchestrator, your registry, you've got revision control of your software, and all these pieces play together to give you that nice pipeline in a virtual software environment. Manage your systems, manage your applications, manage your users. It's very ephemeral. When we go to the OT side, we don't have that at our disposal. These are physical systems connected to physical computers or physical devices that are controlling them. How do you maintain that? There's no ephemeral aspect to that. It is a physical system, and we have to work with it in that sense.
You're leaning a lot on vendor capability at this point, because there are a very small number of vendors playing into this piece that are actively providing product to many of these industries. So we're really relying on process and procedure, as much as I hate to say it, like something like the Purdue model, where we're looking at the different Purdue models and we're evaluating, this is Purdue model 2 and 3. We really need to secure at Purdue model 4, because this is the only area we have control of. And that means giving us visibility into the HMI or the historian and providing some logging that then has some security features that feeds out, to Purdue level 5 and out to the business application where security people actually have some visibility. The problem is there's inside of IT and OT, there's a whole bunch of security people in the IT side of the business side of these corporations and companies that are protecting the business model. But the data that's being fed out of OT and the capabilities that OT is managing and protecting, there's not a whole lot of support or resource or FTEs inside the OT environment to give a good visibility and an understanding in the framework of here's how we tackle OT security, and we feed that back to IT security so that they can help us react, provide budget and FTEs for people that know what they're doing.
It's interesting when I look at the group of extremely smart hackers, essentially, that were building the first routers for the internet. One of the things that they did, and they were very concerned about uptime. They're like, what happens if one of these routers fail? I need to build redundancy in. And they created hardware and software that worked in tandem to basically say, if something went wrong in the software, it would read from a paper tape, not a punch card, but an actual tape.
Paper tape,
a tape, and it would read back and sounded like basically rebuild the firmware. They didn't really call it firmware, but rebuild all of the software that ran on that router, and they would try and run again. And it may be fuzzy on the technical details, but it sounded to me like if it ran into another problem and still couldn't, that in that paper tape there was basically the same copy of the software, and it could read that paper tape up to 3 times before a physical person had to go in and do that. It sounds to me like maybe there probably already exists for hardware devices in OT that could do the same thing. Let's say an attacker does corrupt the firmware. Are there ways to essentially have that physical backup to be able to rebuild that device on the fly? I'm sure that technology exists, and if it existed in the late 60s, right, by the engineers at BBN, I'm sure we have similar capabilities today.
So many of the the real-time operating systems and PLCs that you're dealing with, as far as companies building these PLCs, they're building in protections and redundancies, because at the end of the day, redundancy does not equal security for them.
No,
they're not thinking about redundancy as a security control where an attacker, hey, if this redundancy fails, we'll fail over to this redundancy. Redundancy is built in as a security and a loss of life or protection mechanism that then, has a secondary added value of security. And so I think they're starting to realize the value of leveraging those particular redundancies, things that they've already done where they're 2 or 3 layers deep on their defense in depth for loss of life or defense in depth for redundancy. And then they're applying some of that to security, like the checksums against firmware and how they're doing the updates and what's able to be pulled off of microchips and RAM chips or devices being deployed inside of hostile environments. These particular pieces are starting to be thought of, but they're only thought of because the redundancy aspect has already been considered.
Right. Well,
power
but it's still
have been dealing
software.
with like people stealing power for decades, right?
Yeah.
Like this is not a new thing for them. It's now, hey, if a hacker does that at large scale, now how do we manage that and how do we protect against it?
A lot of it still today is done in software. What I liked about the BBN solution was it was a physical paper tape, right?
Yes.
It's hard to replicate today, right?
Yeah.
I don't know how you replicate that
If
today.
not impossible, right, to replicate that.
Optical?
Optical, maybe?
I'm not sure.
Oh, boy.
Paper tape, you know.
Well, it's been
pick those things up cheap.
I mean, that's a good piece, right? Like, there's a ton of ICS things. Like, if you look at the news over the last 4, 5, 6 segments, every time we're doing a piece of news, there's always something in there about either a country, a nation state, an APT, a industry, ICS, or some kind of.
You mean like the
mechanism that's being
unidentified ransomware strain that shut down a natural gas pipeline for 2 days?
Yep.
I had that
Yes,
story
I mean
as well.
this is obviously becoming a newsworthy thing because these are targets that are providing kinetic impact and or advantages for an APT group, or B, they're easy targets because of where they're at with inside of their security maturity model.
But I think the term ransomware in this context is you can't pay the there's no ransom. They're not doing it for ransom. They're doing it to take out infrastructure. It's a denial of service attack, essentially, at that point. NotPetya was that example.
Disinformation, right?
Right. It was, that's part of their, they want to say, oh, it's ransomware, you can pay this ransom, right? But NotPetya, there was no way to pay the ransom. They were just wiping out systems so they could disrupt.
And is that a test bed? Like, is NotPetya a test bed in order to develop the next level of, hey, here's how they combated, here's the things that, lessons learned that we had from the last 5 ransomwares.
I think you're right on the money there.
That to ICS?
Yep.
And you can shut down these ICSs because a lot of times they're dependent. Because, again, like what Tyler was talking about uptime or your tape, if I can cause the historian to lock up, the whole system may shut down. So you may have a historian that's running Windows XP, and if that stops and the system keeps sending inputs to it and they're not getting replies, the system may literally shut the whole works down because they say, well, we're not documenting, we got to shut down. So it could just be denial of service or a test by the military, some military that wants to say, well, NotPetya may have been a test just like that because they say, well, if this will work here, everybody uses these same systems. We can practice our attacks, and then if we want to move this attack and take out Toronto, we can do that.
Well, I mean, you look at something like Sandworm, which I know you're near and dear to your heart.
I did. That was a great book.
From a listening standpoint.
I did. Well, I finished that one, and it was a great. I listened to it. It was great.
Yeah, I mean, you look at something like that, and there are things that did not make the public kind of seen that, hey, this may have been a test in order to identify particular peculiarities in a device that is distributed somewhere else, or hey, this was attacked and there are these other pieces that did not get reported that now become an important fact of that long-term strategic game that people aren't thinking about or even looking at because, hey, we're moving on to the next thing. What's Trump tweeting about this week? So like that short-term mindset versus long-term mindset and getting that attacker's kind of long-term game just brings back the picture of how you have to identify these attacks. And really, as an organization or a government even, you kind of have to think strategically and organize where your defense in depth goes and how you respond and or alert the attacker that you're either detecting and defending against this or seeing these particular attacks and seeing what's playing out for the long-term game. So that's some strategy that not a lot of people are either employing or talking about, which
I think
is happening.
I think it's an interesting point, Tyler, because it's never like a failure is never truly a failure in this scenario. And we can look at many different attack campaigns, Stuxnet included, and many would call that a failure. But if there are groups that are looking at that and going, well, okay, let's see what happens when this runs out of control, and let's see what everyone's response is so that we can start planning the next thing. And the next thing's really just a test for the next thing. Yeah. My fear, being in security all these years and looking at everything is happening, is like, when does all this culminate into like a really big disaster? And I don't want to spread FUD, but that's kind of where my head's at now like these are not, because we, I think as security analysts can look at, especially something like Stuxnet and go, wow, they were really stupid. Why'd they let a 0-day leak? And the reason they would do that is that there is some great benefit. That was not an accident, in my opinion. I don't think any of this stuff happens.
There's a very short timeline. They have very specific goals that they have to meet, and they're not operating on their timeline. They're operating on someone else's timeline that has some very, big ramifications if they don't get this right. And so the fact that they blew a few 0 days in the big strategic game of what they're playing, that's a pretty small price to pay for what they got out of it.
It's a game of chess,
from a visibility.
Yeah.
Military plays long run too.
They lost a few of their pawns, whatever. Right. That was part of the whole. That's part of the whole strategy, right? The strategy is to win the game, and losing a few pawns along the way is
they're just
whatever.
Pawns.
But I think they rely on some of us folks to go, well, that was really stupid. Why'd they burn a 0 day, right? To kind of make people gloss over the fact that this is really an ongoing chess match between all of these different nation states.
That's keeping that long-term strategic mindset, right? Like, that's the piece that, as hard as it is to do, like, it's easy to get in the weeds. It's easy to see, like, the single campaign or the single, you're diving deep on a particular incident. Getting that and keeping that, like, long-term strategic view of how this plays into the whole picture from a political, business, financial and or governmental understanding, that game is what's important, and that's what a lot of people need to adopt in order to provide real value and make a difference long term. I don't think enough people are thinking about this.
Kind of scary. You can look at the Marvel, the MCU timeline, and look at wow, Thanos made some really terrible mistakes, but were those all eventually he did really wipe out half the galaxy. And achieved his goal.
Long-term goal.
Luckily we had, it's movies, so we have time travel, but had we not, that goal was achieved. Talk, right? But if you look at
something like Thanos' timeline, that's a great talk. How do we take and apply something that we get visibility into in a short timeline, such as a video?
You watch one movie,
that to
right?
Looking at from a strategic standpoint of political and economical standpoint from a country's. That's a big deal.
And there may be a game you don't even see with all that stuff, too. There's a chess game, but there's really a different chess game that's underneath it.
3D chess.
That chess game you're looking at when you're trying to think
the one they want
ahead,
you to see,
It's the one they want you to see, and it's really part of a bigger scheme that says let's destabilize over 50 years, and then at the end of that, and all these little pieces are just games we play in the meantime, tactics, strategy, Thanos was just a pawn too.
Well, it could be. We're just, we hope we have the tone.
Which is important, right? We really, as Western civilization and as our Western mindset comes into play, we really do have to understand that, these are bigger issues that may be outside of our capability to understand, but we have to think about those long-term games, and we have to get outside of whatever preconceptions and pre-notions we have as, U.S. citizens or Western civilization on a very short term. We have a very short history. We have a very short technology span, and our ability to kind of think about these long term has to start to come into play, because what we decide now are going to affect not only our children but our grandchildren. And so
we just, whoever's going to win has to have the Ant-Man and the Iron Mans of the world to invent time travel, and then that's who wins, basically.
TikTok is not going to save you.
Which is kind of sad that's how it ended. I hope I didn't spoil anything for everyone, but if you haven't watched it by now, a 5-inch piece of electrical tape can fool Tesla sensors. Yeah, Tesla technology is bit. Kevin Finisterre, if you ever want to get insights into Tesla and automated cars, his post on Facebook and largely Twitter too, I learned stuff about Tesla and automated cars that I had never considered before.
Yeah.
Following our good
that
friend
technology is in everything now. So that sonar system that they've got is in every even the one. If it doesn't even have autonomous capability.
Those sensors, because there was a story where drones were projecting an hologram,
and they were projecting the yellow lines and stuff like that
to steer. But what was the electrical tape thing?
Well, the electrical tape was the same kind of test. They're just putting electrical tape on the street and causing the vehicle to respond to it.
Interesting.
And in showing how somebody could very easily cause major problems just with the simplest little hacks. That it was like those guys that were embedding SQL injections in their license plates.
Yes.
And the camera, reading that into the data. Yeah, I was like, that's pretty cool.
You're looking at something that you're talking about ML, right? Or you're talking about heuristics or anomaly detection at this point.
Yeah.
So the ability for a computer to make an educated guess, we're very, very early as far as the adoption and capabilities.
Now, wait, educated guess, we call that machine learning, Tyler, right? Is that
I do.
Well, it actually
air
is,
quotes,
Make a
educated
weighted guess, just like
it
I
kind
do.
of
Like,
is.
It kind of is.
here's the options. Here's my preconceived notion of what's going to happen. Here's my motivation. So I'm going to weight this way heavier. I'm going to make a decision.
Yes.
Right? Like that's all ML is.
We
at
should
kind of
just
a
let the
high level.
Whopper determine whether it's global thermonuclear war or not, right?
Exactly. Right? Like, so you're talking about very, very simplified versions and early adoptions of these particular technologies. And Tesla in particular has been very, very forefront on doing many of these kind of early adoptions because they like to be a forerunner. So the fact that their cars are able to be, misrepresented or tricked into doing certain things
I like
based on very, very small...
I like your forerunner car pun in there too. That was good. That was good.
Yeah, they're able to do these things, and they're doing these things kind of, early on. That's not a surprise, and as security professionals, we shouldn't feed into kind of the FUD around this. This should be expected from an ML perspective.
Agreed.
As you're adopting it and as you're learning these particular weighted decisions, and as the algorithms grow and improve and get better, these weighted decisions, they can be fooled, but they may not be able to be fooled as long term as what we're thinking.
And
Again,
this is a long trail. I mean, AI research started in the
30s,
30s, even earlier, right? Earlier.
Turing was writing about
earlier than that. But if you look at how it's progressed over time, I'm astonished how early it started, and the slow kind of curve, right? I mean, we're not jumping from stuff that can do automated chatbots on a website over to completely autonomous AI like we have data in Star Trek, right? Like
Hunter killer bots.
This is a slow, my assessment.
But I mean, we're being so hard on autonomous vehicles. I mean, we're holding these poor autonomous vehicles to a standard that we would never hold humans to. I will bet you if we went out there tonight and we painted white lines curving off the road into a brick wall, people would follow the white line. There was a guy in Rhode Island got arrested 2 times in one day for DUI because he ran into like police cars and all this other stuff.
There was a case where someone there was an automated vehicle that crashed. But it wasn't it was someone hit the automated vehicle.
Yeah, and then they blamed the automated vehicle,
Island, wasn't it?
Yeah, I think it wasn't Rhode Island.
Yeah, and I mean, if you went out there and started manipulating the street, and I'm not saying that we don't need to deal with this stuff because people are going to do that with autonomous vehicles, but we can manipulate humans just as easy. I mean, people go out there and
my friend.
Tell me, people can parallel park a car as well as the parallel parking AI.
They can have They can have smart park.
Smart park. Go out there and take a hand-painted cardboard sign that says "Proceed, do not stop," and hang it over a stop sign, and people will be blazing through the intersection and getting killed.
So in high school, Bob put those construction cones in the middle of the road, and just to see like people's reaction, and it was exactly what you're saying.
Of course,
people react to whatever.
I mean,
these are people, not automated vehicles.
How many of us have social engineered campus? I used to work at a university. We carried a traffic cone in our car.
Yeah,
I would set it out when I got there so my friend would have a parking space because he didn't come in till later. I would set it there, and people go, "What's going on there?" "Oh, this space is out of service. There's a sinkhole underneath it. You don't want to pull in there."
Yeah, I think security professionals are harder on AI or ML because, for one, our decision-making capability is typically higher than the general population. Like, that's not like a bragging statement or some kind of like a superiority piece, but the ability to make an educated decision based on A, weight, and B, logic. We typically are able to make those decisions very well because that's our analytical mind. That's what we're trained to do. That's how we build programs or programming languages.
I don't know if I told this on the air, but some of the first programmers and hackers, when their wives would ask them questions, they were coding 60, 80 hours a week and doing some of the pioneering research in software engineering. And their wives would ask them, "Would you like to help me bring in the groceries?" And they would say no. And their wives would get really mad, but it's because their brains were just like wired for that kind of logic. And finally, push comes to shove, and I can see this because my wife and I think have very similar interactions. Sometimes wife kind of like confronts, and it's like, well, you ask me would I like to. It's like no one really wants to help do manual labor. If you just ask me, please, help me take in the groceries, well, that's an instruction that I can understand. To your point, Tyler, right? Like those that are writing software and working with the technology kind of develop that computer logic kind of mindset, right? And it's highly annoying to other people that don't have that mindset, I guess is my
You're not
point.
talking the general public. The typical 98% of the population does not have that logic gate in which we're analyzing and weighing each decision based on full logic and scope of the weight. Like it's not happening.
And the inefficiencies kill us, right? Like they really like truly pain anyone that writes software. I mean, just any kind of software. I don't care what kind of software that you're writing, right? Like it being the most efficient in software translates into your life, right? Like why are the forks not near where we have the plates? Like that shit drives us nuts, right? Because that was a computer program, and I had to jump through all those different drawers to get to the forks. That's bad, right?
Just put flow charts all over your house; it'll help. Yeah.
But the same thing of people
need to be felt next to the sink.
Yeah, but people in lean manufacturing have the same mindset, right? Like they understand the efficient manufacturing processes, right, and have the same like freakouts. I know friends of mine that worked in lean manufacturing, and they'll visit cigar plant where they're rolling cigars, and just like and if they see inefficiencies, it drives them insane. Same thing.
Yeah. So I mean, we really have to be taking these ML or AI headlines as far as like what they're saying. Like we've come a long way. What's being adopted as far as what's being allowed on the road from that standpoint, and these things are going to be in play for 30 years. Like that's a feat in and of itself. And we have to kind of realize what that's actually saying.
Well, and I think what Mike and Poor and Larry are working with GPS also plays into this as well. Because this is a common debate that I'm sure many of us have with our family members. When you plug something into a GPS, you're like, the fastest way to get there is really just math. And now you factor in things like traffic and construction. It's machine learning, which is really just more math arriving at a decision, right? And you're like, that's the most efficient way. And I think people that don't think and haven't done software and technology are like, well, no, I know if I go this way, like if it may, I'm like, it feels.
My dad's nuts.
Right? It feels faster to you, but I'm like on my phone and I'm going, no, the computer's telling me this is. And I understand there's some variance in there, but the computer tells me this is a faster way. But now if you can manipulate, I mean, we've seen this in science fiction a million different times, right? You manipulate what the computer's telling you, and you could very much be in the wrong if a hacker has modified that GPS to send you through a certain area. That the integrity of those systems are extremely important.
There's some serious finite pieces of this equation, like globally, that as security practitioners, we really have to start to identify and realize that these are critical aspects of how we do day-to-day life. Things like time, things like clock, things like GPS, where precision is important, and all of these X, Y, and Z systems rely on these particular data points in order to accurately and definitively provide a safety and or the next
but I mean,
decision.
Hackers aside, important. They get it. The computers get it wrong. I was stuck in traffic, actually going to present at a local security meeting. I mean, massive amounts of traffic. The GPS sent me off on an exit, and I'm like, great, it found a way around the traffic. No, it sent me off on the exit to cross the street and get on the on-ramp and get back into traffic.
There you go.
Because it thought that would save me time. And I think many would like want to just throw their phone out the window and go, I'm never using GPS again. But I'm like, well, the computer made a decision that was faster. Maybe I did save 10 seconds. Who knows?
My favorite was used to in Boston. Garmin would get you off.
Boston's like, I mean,
no, I know, but Garmin would get you off of like main roads and put you in these alleys and stuff because on the maps, the alleys had a speed that was not reported. So essentially, it was infinite speed.
Right.
So, if you take his alley.
In some of those alleys, you want to go at infinite speed.
Well, yeah, and I didn't even want to bring that up. But like where it's routing you through Morningside Heights, and, you're like going, I was going really fast through there because they were shooting at me. So I did save a lot of time.
I've been there because my mother-in-law grew up in Massachusetts and outside Boston. and the GPS did exactly what you said.
Oh, yeah, no, I've done
and she's
that,
like, we're not. I'm like, but
We're
this
not
is
going
the
down that
fastest
road.
way. And she's like, no, we need to turn around. Like, no.
That's a bad road.
So there are things that, computers can't figure out that humans can, which is scary.
I mean, we were talking about news, right? What's next on the news?
We are. I think did Lee drop off?
He did. Yeah.
Okay.
I think so, yeah.
About an hour ago.
He had a bunch of stories. In any case, hackers are actively exploiting a 0-day in WordPress plugins. I just, and we cover this all the time, I think that the right way to implement WordPress is to really take some ownership over all the code. Anytime you come to a decision point that you're going to implement a theme or a plugin, you need to validate that as best you can, right? Whatever skill set you have, ask people who have that skill set and evaluate it. And I think there's some really good indications, those that are advising people that are implementing WordPress, right? You need to, if you're highly technical, take the reins and implement things such that it's the most secure code that you're implementing on that platform. If not, use common sense, right? Like, if it's a free plugin and it doesn't have a lot of downloads, there's a high degree of possibility it's going to have vulnerabilities. You want to stay away from that.
How do you disseminate that to like the general population where it's easy
hard
to build like a Bluehost or like something that's relatively easy? Like this happened to Corey and I this week. We actually I was showing him one of my friend's classic car builds. He's building engines for like people worldwide, like very, very specific builds. And we go to a site and Corey's like, dude, this site is like popped. Mm-hmm. Like I can't get there. He's getting redirected. So we look at the site, and sure enough, like it's a very, very simple, a known adware and issue with inside of WordPress, and they got popped like years ago.
Yep,
like, long time ago. But they never know. They didn't even know they had a website. They knew they stood up a website. They put a phone number on there, and they post pictures once in a while from an app on their phone.
Yep.
So how do you like disseminate that knowledge to the general public so it's not a being used as either a botnet or an adware redirection or infection vector, or B, like how do we like deploy these and maintain these long term for the average public person that's not going to ever look at this again? Like these are problems that are getting more and more prevalent and have to be addressed in a different way.
Because it's solvable in software, even with WordPress, right? Which is highly vulnerable, obviously, right? But it's solvable. I mean, with immutable infrastructure, conceivably you could just rebuild the site every hour for that person that maybe wants to post a picture, and give them a process that, hey, when you post a picture, it ends up in your build. If someone from the outside, right? If someone from the outside modifies your website, well, guess what? In the next hour, that's going to get wiped away. Maybe there's some kind of AI that fixes the vulnerability, is updating it, taking your updates and putting it in. Like, I think there's ways to do it. I don't think there's an economic driver similar to IoT that allows people to evaluate where I'm hosting my website and what's giving me the more secure process.
And there's not a lot of incentive for the people hosting these websites, right? Other than maybe bandwidth, which I think they could correlate some dollar amounts to like the bandwidth side of this and like what traffic's being populated through these like very small sites.
Yep.
But at the end of the day, like they don't have any incentive to help these mom and pop shops that are paying them, $20 a month maybe.
Right.
To
it is more expensive than I think $20 a month, but and again, being security people, we research the company very heavily, and they are in no way a sponsor of the show, but I'll give them a plug because they've been an awesome hosting provider. We use WP Engine to host our WordPress sites. That gives us what I believe is a very good minimum level of security for WordPress. And they do a couple of things. One, make it super easy to update WordPress, and then they'll scream at you loudly if you haven't upgraded. And I think even when push comes to shove, they'll just shove you to the new version. The other thing they do is if you install a plugin that has known vulnerabilities, they'll send you a notification and be like, you got this, you want to take care of it. By the way, if you don't, we're going to remove it. And they'll just rip that plugin right out of your site. And I tell you what, they're an awesome hosting provider for even just those reasons. And they maintain also your PHP version and are very aggressive at pushing your site forward to the next version of PHP. And every time I've gone in there, I go to the next version of PHP. I mean, knock on wood, I've never had And if you do have an issue, now fortunately, we haven't had a security issue on their platform, but I've had other data migration issues. At one time, I contacted support to ask them a WordPress question, and I got pushed to what I'll call their ninja level, and I was impressed. I mean, these people know WordPress inside out and backwards. They are ninjas, and helped me out in that one instance where I was like, I'm kind of stuck between what do I do? And they told me shit about WordPress that I didn't know. I was like, you guys are awesome. So bringing that to a more, I think it's the IoT problem, letting the public know that there's a difference where you host your WordPress site, and you should go with someone who is providing a basic level.
Right.
And I'm not saying that if you host there, you're going to be bulletproof, because we all know that's not a thing.
Still on you.
But you're in a much better position to be secure, but in a much better position to bring yourself up to those more secure versions and get notified when you install the crappy plugin. This one's like Theme Rex plugin. I guarantee you that's one. If I installed it on WP Engine, they'd be like, Paul, what are you doing? You're on crack. Get that plugin off here, right? That's awesome. That's where we need to be to secure something, because the functionality in WordPress is amazing, and that's why people use it. But having a provider, I think, that gives you that level is what sets you up for success. Again, never 100%.
Which is outside of the marketing FUD and what's being provided as far as what you think from a marketing standpoint. Like most people think, I can go to one of these 4 big name brands. Yep. I'm not going to name any of them, and I'm going to be secure because they know what they're doing. If we should tag these people that are doing a good job from a security standpoint, looking at you, Johnny, to tag at WP Engine, and get these people on so that people understand and know and have that visibility around the people that are doing a good job, because it's not often called out. We spend a lot of time calling out people that are doing a bad job around security, but we're not often calling out the places that are doing a good job and where we should be turning our resources and money to. Often people are asking us, where should I be putting my budget to? What companies and products do you see actually working? Those are the questions that are coming directly from clients. That's outside of even the security industry. So providing some incentive for these companies to do a better job and then be recognized for the job that they're doing outside of being told they're failures. We got to really start promoting those positive aspects of this and build some of that.
Theoretically, if you do that, the market will drive you away from a lousy provider towards a good provider that will provide those services.
Well, and hopefully as people host with other places and have had security issues like your example, Tyler, giving them a place to go once they've had it. Ideally, we not let them have that bad experience of being hacked and having adware on their site, but driving them to the more secure places where they're set up for success. A lot of these hosting providers, even WordPress aside, a lot of these hosting providers don't care, right? About security at all. But it's important, whether you care as a business about the security of your website or not, it's going to be an impact to your business once someone takes it over or takes it out entirely, right? Yeah. That's a business cost to you. Avoid that cost entirely. Go to a place where you're set up for success.
Yeah, return on investment from a business standpoint, like this one single example, they've been paying this hosting provider for, maybe 3 to 5 years. Anybody that's visited their site in particular looking for them to get a phone number has been redirected and not gotten that phone number. $20 a month, that seems like a pretty instant ROI from a business standpoint. And you can calculate that and expand that into any number of different business aptitudes in order to make this number work. And that needs to be addressed from the offensive side and from the security side. We always have to bring back the business standpoint, the return on investment, and the economic or financial pain points in order to show the value of what we're doing. Otherwise, what's the point? We're all capitalists. We're all here to make money and to do that better. So we have to kind of understand that and adopt that and be able to promote that and articulate that in a manner that business understands.
Yeah. Well, I think that rounds out the show for this week.
I think so.
Doug, Tyler, thank you very much. And thank you, everyone, for listening and watching. Doug, take us out.
Well, I think we're just about out.